Imagine the universe's most extreme entities locked in a cosmic battle, a dance of unimaginable forces and energies. Black holes, the universe's ultimate vacuum cleaners, face off against their hypothetical opposites, white holes. These enigmatic entities represent the yin and yang of cosmic phenomena. Black holes, with their immense gravity, devour everything that gets too close. Stars, planets, and even light cannot escape their grasp, disappearing into an abyss of darkness. White holes, on the other hand, are thought to be fountains of matter and energy, spewing material out into the cosmos. They are the theoretical counterparts to black holes, expelling what black holes consume. What would happen if these cosmic titans collided? The collision of a black hole and a white hole is a scenario that stretches the limits of our scientific understanding. The clash between a black hole and a white hole is a mystery that ignites our imagination. It is a cosmic event that could potentially reveal new physics and unknown aspects of the universe. It pushes the boundaries of our understanding of the universe. Such an encounter could provide insights into the nature of space-time, gravity, and the fundamental forces that govern our cosmos. It makes us question the very fabric of space and time. Could such a collision tear the fabric of the universe, or perhaps create new realms of existence? The possibilities are as vast as the cosmos itself. Black holes are regions of space-time where gravity's pull is so strong that nothing, not even light, can escape. These cosmic giants are among the most mysterious and fascinating objects in the universe, warping the very fabric of space and time around them. They are formed when massive stars collapse at the end of their lives. This dramatic event, often marked by a supernova explosion, leaves behind a core so dense that it creates a black hole. Imagine the Earth squeezed into a tiny marble. That's the kind of density we're talking about. The matter inside a black hole is packed so tightly that it defies our understanding of physics. The boundary of a black hole is called the event horizon. This is the point of no return, beyond which nothing can escape the black hole's gravitational grip. Once you cross this point, there's no turning back. The event horizon marks the edge of the black hole, and anything that crosses it is lost forever to the depths of the black hole. The gravitational pull inside the event horizon is so intense that it stretches and compresses matter, a process known as spaghettification. This extreme stretching is due to the immense difference in gravitational forces acting on different parts of an object. Unlike their dark counterparts, white holes remain shrouded in mystery. They exist as mathematical solutions to Einstein's equations of general relativity, but we've never actually observed one. Imagine a black hole running in reverse. Instead of sucking matter in, a white hole would constantly expel it. Some theories propose that white holes could be the birthplaces of new universes, or the other end of black holes, connected by hypothetical tunnels called wormholes. Section 4. Bridges through space and time? Wormholes are theoretical shortcuts through space-time, connecting distant points in the cosmos. Imagine folding a piece of paper in half and poking a hole through it. That's a simplified way to visualize a wormhole. Some scientists have theorized that a black hole and a white hole could be connected by a wormhole, creating a bridge through space and time. However, the existence of wormholes remains highly speculative. We don't have any observational evidence to support their existence. Section 5. When universes collide. Imagine a scenario where the very fabric of space and time is torn apart by the collision of two cosmic giants. The collision of a black hole and a white hole could have mind-boggling consequences, altering the universe in ways we can barely comprehend. Some theories suggest that it could result in an explosion of energy unlike anything we've ever witnessed, a cosmic fireworks display that would outshine entire galaxies. Others propose that it could create new matter, giving birth to elements and particles that have never existed before, or even spawn a new universe, a fresh canvas for the cosmos to paint its wonders upon. The truth is, we don't know for sure. The mysteries of the universe are vast and often beyond our current understanding. The laws of physics as we understand them break down at the singularity of a black hole, where gravity is infinitely strong and space-time curves infinitely. Until we have a better understanding of quantum gravity, The true nature of these cosmic collisions will remain a mystery, a tantalizing puzzle for future generations of scientists to solve.